This is the screencast for section 9.4, example 1. We're going to get introduced to infinite sequences, well, sequences in general in this section, but in example 1, infinite sequences. Now there are two types of sequences, infinite and finite. A finite has a set number of entries, an infinite sequence has an infinite number of entries. A sequence itself is an ordered progression of numbers. So because it's ordered, we have to come up with a general way to name each entry of the sequence. So we might call a sub 1 the first one, a sub 2 the second, a sub 3 the third, etc. And depending on how many there are, so sometimes we don't know that, we call the last one a sub n, and then the second to last a sub n minus 1, the third to last a sub n minus 2, etc. So depending on how many are in the middle, you might easily be able to write a sub 1 through a sub 10, but if you don't know, you might have to use a more generalized expression. Now your book seems to use a sub k and a sub n a little bit interchangeably. Both of them stand for a specific spot in your sequence. Our goal throughout this section will be to come up with rules and different ways of expressing and defining a sequence and or series, which you will learn about in the next example. One way to express this rule would be explicitly, and that is to define the terms of a sequence as a function of k. So if k is 1, what do you do to that 1? If k is 2, what do you do to that 2? So example 1 is telling you it's defining a sequence explicitly. Find the first 6 terms and the 100th term of the sequence a sub k, in which a sub k equals k squared minus 1. So k stands for the first, second, third, basically the placeholder of the term. So a sub 1, I'm going to take my sub number and plug that in. 1 squared minus 1, which would be 0. A sub 2 then would be 2 squared minus 1, so 3. A sub 3 would be 3 squared minus 1, which would then be 8. And we'll keep going all the way through the 6th term, and then also plugging in the skip over a bunch and go to the 100th term. So by using the explicitly defined rule for this sequence, I was able to identify what the kth terms would be. The now try problem number 1 is asking us for the same setup. Find the first 6 terms and the 100th term. They called this sequence u sub n. So u sub 1, I would take the number 1 and plug it in for each n. So 2 divided by 1 is 2. U sub 2 would be 2 plus 1 over 2. So 3 halves. U sub 3 would be 3 plus 1 over 3. And of course you're seeing the pattern. 2 over 1, 3 over 2, 4 over 3. The next one's going to be, that's right, 5 over 4, etc. And there are my first 6 terms and my 100th term using this rule for this explicitly defined sequence.